So our last video for the so-called Tuesday class on fluids is about Archimedes' principle. An example of Archimedes' principle is when you are in a swimming pool, you might notice that you feel lighter than you usually do. Or if you're exercising in a pool, the weight on someone's knees and joints is significantly less than if they were working out in the air. The reason for this is the same reason that things with a lower density than the fluid they are in float. There is a force called a buoyancy force, and it is applied when something is suspended in a fluid, and we want to understand where this buoyancy force comes from. The buoyancy force comes from the fact that the pressure increases with the depth in a fluid. That means that the force applied to the bottom of something in a liquid is larger than the force that's applied to the top of the object. This results in a net upward force on any object that is in a liquid. If the buoyancy force is greater than an object's weight, like a helium balloon in air or a duck floating on a pond, then the object will float. If the weight is greater than the buoyancy force, then the object will sink. If the buoyancy force is exactly the same as the weight, then it will remain suspended at that depth. Notice that the buoyancy force is always there, whether the object sinks or floats. So to look at this more quantitatively, let's look at the pressure on a rectangular box suspended in a liquid. The pressure on the top of the box will push the object down and will have a value of rho GH, where h is the depth of the top of the box. To get the force, we would multiply the pressure by the area. If we assume the box is straight up and down, and the pressure on the sides of the box will cancel each other out, and they will be perpendicular to the height, so they will not affect the buoyancy on the box. On the bottom of the box, the pressure is pushing up, and the pressure is rho g times h plus the length of the box. And we multiply that by the area to get the force. Notice that the pressure on the bottom of the box is pushing up and is larger because it is deeper in the fluid, while the pressure at the top is lower and is pointing down. When we add the forces together, we get that the buoyancy force is the density times the g times the area times the depth plus the length of the box minus rho gh times the area, where h is the depth of the top of the box. Subtract them, and the net force is rho g, length of the box, times the area of the box, which is the volume of the box. Notice that this is the density of the fluid, not the density of the box. That means that the buoyancy force is equal to the weight of the displaced fluid. So, multiply the density of the fluid times the volume of the object, and you have the buoyancy force. Notice that if the density of the object is less than the fluid, then the buoyancy force is larger than the weight and it will float. While if the density of the object is greater than the fluid, then the buoyancy force is less than the weight and it will sink. This should be clear if you draw your free body diagram. The weight force is pointing down and the buoyancy force is pointing up. This also tells you how deep something floats. If something has half the density of water, then 50% of the object will be submerged, because that is how much the water it needs to displace. If you have an iceberg that has a density of about 92% of water, then 92% of that iceberg will be submerged. Also notice that the density of an object includes its entire volume. A bowl that is filled with air displaces a volume that includes the air at the center of the bowl. So you can make something float that is made of materials that is more dense than water. It just needs the average density needs to be less than water. Okay, so you have some problems to do here. These also should be pretty straightforward. I think the key is that you need to multiply the density of the fluid by the volume of the object to get the buoyancy. So if you use the density of the object by the volume, you just get the mass of the object, and there is usually an easier way of finding the mass of something solid. So use Archimedes' principle to multiply the volume of the object by the density of the fluid that it is displacing, and that gives you the buoyancy force. Then compare the buoyancy force to the mass of the object and its weight force, and that helps you figure out whether it will float or if it will sink. Okay, so that's it for this so-called Tuesday lecture. Good luck and take care of yourselves.